Hello, welcome to our mathematics class, of which today we are going to look at the equations with fractions. As earlier seen, we have seen that equations involving all numbers. We have been able to solve them. We've worked out various methods, especially solving them systematically. Now today, I want us to consider fractions. A fraction is simply a number written in such a form, a over b, and we said when you have a number written in that manner, a over b, it simply means a divided by b. This is a fraction. And we want to look at those equations that involves fractions. Now, I want you to consider the following equations. Now, looking at these two equations, both of them are telling us 2x plus 3 over 5 is equals to 7. And the second one is telling us 2x over 5. The second one is giving us 2x over 5 plus 3 is equals to 7. Now, I want you to be very keen to observe this. When we have a bar that's lying along, where we have all the numerator, that is 2x and 3, while here we only have 2x over 5, while 3 is independent. So these are two different situations. It is involving fractions. However, the whole of this one forms one fraction. This one, only 2x over 5 forms a fraction, while the other remaining 3 and 7 forms the whole number part. So when you consider this, you realize that for us to solve them, the way you solve this one is not the same way you solve the last one. Let me add even another one. I've added, this is just different ways of writing this problem. But for this part, the second and the third are the same, simply because when you open this bracket here, you'll realize that we shall have 2x over 5 plus 3 is equals to 7. So B and C have similar approach, while the first one, A, 2x plus 3 over 5, is simply different. So it's very important, while working out equations with fraction, we should be very keen to know exactly the type of fractions we are handling. Now, this means that we need to note the following, and that is what we shall observe as we solve these particular questions. First, we should note that A over B is the same as A divided by B. The second one we should note is the same one we are looking at here, where I should not take this, do not treat this the way you treat that. It is different. For this particular case, by inspection, you will first start by multiplying by 5. And as you multiply by 5, then you'll find that this one will be eliminated, will remain the 2x plus 3, and this one will give us 7 times 5, which is 35. So I want you to see this. From this, we shall first eliminate by simply multiplying by 5. But for this one here, the first step, this is the first step here, but for the first step here, you realize that we shall first subtract 3 both sides. So here is minus 3, and here minus 3, so that you have 2x over 5 is equal to 7 minus 3, which is 4. So take note of the difference between this and that. So for this now, having eliminated the 5 by simply multiplying by 5, now we can go ahead and now subtract 3 here for both areas, so that we remain with 2x is equals to that 5 minus 3, which is 32. And the next step we shall follow here is divide by 2, divide by 2. You'll find that 2x divided by 2 is x, and 32 divided by 2 is 16. So you have your answer there as 16. But for the other end, having reached here, you'll be required now to multiply by 5 here, multiply by 5 here. So to multiply this one by 5, you'll remember with the 2x is equals to 20. And divide by 2, divide by 2, you find that x is equals to 20 divided by 2, which gives us 10. So you see where we started and where we've arrived. The approach, which is very important, is if the whole of it forms one fraction, we go straight forward to multiplying by the denominator. But where we have broken fraction and a whole number, we eliminate the whole number first by simply subtracting there, and then we come up to another expression where we now move ahead to eliminate the denominator. So we must observe that particular rule. Now, we should also have the idea of the following while working out this. Now we are saying here that if neither side of an equation is a fraction, if neither side of an equation is a fraction, then do not multiply by the denominator. If neither side of the fraction is, if neither side of an equation is a fraction, then do not multiply by the denominator. What are we trying to say here? We are saying this. If you have, for example, x over 3 plus 5 is equals to 8, what we are saying here is this. Neither side of the equation here forms a fraction. So this one is different, this one is a fraction. So we are saying here that do not multiply by the denominator. Do not multiply by 3. Don't. But the best approach, what should be done here, do not. So the issue of expecting you to multiply here by 3 and here by 3 is wrong. Avoid, you must avoid that completely. So what should be done instead? The very first thing is to deal with the whole number. So we shall expect that we first subtract 5 here and subtract 5 there. That's the first thing. So that now we reduce it and remain with a single fraction. So this one will give us 5 minus 5 is 0, so we shall remain with x over 3 equals to 8 minus 5, which is 3. Now, having reached there, now you are free. Now you can multiply by 3 here and multiply by 3 there to have x is equals to 9. This one is the correct approach while approaching equations whose neither side of an equation is a fraction. Sometimes, you should note this, that sometimes it is wise to swap the left-hand side and the right-hand side. Sometimes it is important to swap left-hand side and right-hand side. Let us look at example why it's necessary sometimes to swap, because it will become easier to handle it. Look at this. 12 equals to x over 3 plus 1. 12 equals to x over 3 plus 1. In such situation, you will find that it will be easier if we swap the right-hand side and the left-hand side, so that we just have it as x over 3 plus 1 is equals to 12. Then we move ahead and solve it. So sometimes we make it easier for us to solve, so it is necessary for us to swap these equations, the left side and the right sides. Now, let us look at how to solve equations with fractions. We want to start solving equations with fractions. Solve each of the following equations. Now we have 4 different equations simply because the approach given to each question here is also different. So we shall look at them all the 4 because there is a different approach at any given point. So we are supposed to solve, remember, not just to simplify an equation, but to solve the equation. And one is a over 7 equals to 3, which implies we are going to look for the value or to solve for a. We have 5y over 3 equals to 10. We are going to solve for y. 3x over 4 plus 7 equals to 13. We shall be solving for x there. And finally, 2x minus 3, all of it over 5 equals to 3. So let us start by looking at the first one, which is a over 7 equals to 3. The approach we are giving here, we are using the normal, approaching them in a systematic manner. So for this case, as we go through it, we have a over 7. The other side, we have 3. Now, take note that this one is already a fraction. The whole part of it is a fraction, so we are going to multiply by the denominator. The denominator that we have here is 7. So 7, a over 7 times 7 gives us a, and 3 times 7 gives us 21. Therefore, for this first part, we have the value of a as equals to 21. A is equals to 21, simply because by multiplying both sides by 7, it simply removes the denominator of 7. It removes the denominator of 7. The second question. Five y over 3 equals to 10. 5y over 3 equals to 10. As we saw earlier on the points to note, we remember that if the whole part is a fraction, then we shall eliminate by simply multiplying by the denominator. So we need to multiply by the denominator here, because the whole of this left-hand part is simply a fraction, and the denominator that we have is 3. To remove 3, we shall be required to multiply by 3. So this part to multiply by 3, this other part multiply by 3. If you happen to do that, then we shall remove the denominator there and remain with 5y equals to 10 times 3, which gives us 30. Now when you look at 5y and 30, you'll find that there is some relationship between 5 and 30, where 5 is a factor of 30. So here, the next step here, we are going to divide by the opposite of 5, but times 5, that is by 5 here, and then here we divide by 5. When you divide 5 by 5, we remain with y, and then 30 divided by 5, you get 6. You'll get 6 as your answer. So here, 6 is the value for y. So you can say when you solve this equation, then y is equals to 6. Remember earlier on we said you can always check your answer by substituting in the original equation and see exactly what you have. But because we already know the correct method of approaching this mathematically, then we have done it and we are sure about it that y is equals to 6. You can always check and confirm with me. The next question . 3x over 4 plus 7 equals to 13. As we saw earlier on that if at all not the whole part of an equation forms a fraction, then the approach is different. We shall not rush to remove the denominator quickly, but we shall first handle the whole number part. So I'll expect you to handle the whole number part here first, and then we come into the removing the denominator. So the first approach here, we shall actually subtract 7 on the left and subtract 7 on the right. If you do that, then 7 minus 7 is 0. We shall remain with 3x over 4 is equals to 13 minus 7. And 13 minus 7 gives us 6. 13 minus 7 gives us 6. Now, having reached there, you find that The denominator now can be removed because the whole of the left-hand side is a fraction. So you can remove the denominator here by multiplying by 4 and multiplying here by 4. If you happen to do that here, the 4 will actually be removed. We remain with a 3x equals to 6 times 4, which gives us 24. 3x is equals to 24. This one here, we need to remain with the single pronumeral, which is x. So we shall be required to divide by 3 both sides. So 3x divided by 3 is x, and 24 divided by 3 is 8. So you'll notice that now, having worked out this problem, then the value of x is equals to 8. X is equals to 8, which can always be also proved or be checked with your question. Now, I brought in this question purposely because there is a difference between the approach given to this and the approach given to this, given that the whole of this one forms a fraction, while this one, it was only one part of it forming the fraction and then a whole number, the other part. So the approach that we are giving here is going to be different from how we approached it there. And that's why I brought in this question, so that you can look at a different approach of approaching the question where the whole of the side is simply a fraction. The question is 2x minus 3 over 5 is equals to 3. Now, unlike just what we did earlier on, the whole of this part forms a fraction. So the very first thing is removing the denominator. And to remove the denominator here, we shall multiply by 5 here, multiply by 5 here. When you do that, the whole of this 5 will cancel, will remain the 2x minus 3 equals to 3 times 5, which is 15. And then we shall move ahead to eliminate 3. We have 3 being minus 3, therefore the opposite will be a plus 3. So we shall add 3 here and add 3 here. So minus 3 plus 3 is 0, so we shall remain with 2x is equals to 15 plus 3, which is 18. For this here, we go straight and divide by 2, divide by 2, and 2 divided by 2 is x. We have 18, 18 divided by 2 is 9. So we can simply conclude here by saying 2x minus 3 over 5 is equals to 3. When you simplify and solve it, you'll find that x is equals to 9, which can always be checked backwards. Now, there are some situations whereby when you are solving for the pronumeral, you don't just always get a whole number. Sometimes you'll get a number that is not a whole number but a fraction. You should know, as long as you have followed the correct method, you have done it using the right procedure, then you should not doubt your answer. So sometimes we have fractional solution. Let us look at fractional solution and see how to approach them. So here we have to solve the following equations, giving your solutions as a fraction. The first one is 2x plus 5, all of it over 4 equals to 3, and 3x minus 4, all of it over 6 equals to 3 over 4. 3 over 4. So let's look at the first one and see how to approach it. When you look at this, the left-hand side, you'll identify that the whole of that part forms a fraction. If it forms a fraction, we shall approach it very fast by removing the denominator. And for us, the denominator is 4. So to remove 4, we shall multiply by 4 on both sides, so that we shall remain with 2x plus 5 equals to 12. Take note that what has happened here, just to illustrate here, when you have 2x plus 5, the whole of it over 4, when you multiply by 4, this one and this one will always cancel. That's why we have remained with this one, which I've transferred here. So we should be comfortable on that. Then from here, the next approach we take is just straightforward. We shall have to remove the 5 by simply minus 5 here, minus 5 there. And when you do that, you remain with 2x equals to 12 minus 5, which is 7. The next step, we move ahead and divide by 2. Divide by 2, you remain with x is equals to 7 over 2. 7 over 2 will remain like that as an improper fraction, or alternatively, you can write it as a mixed fraction, which is simply 3 and a half. 3 and a half. So the value of x is either 7 over 2 or it is 3 and a half. What I'm saying is this, that we have fractional solution, and that's why these values of x are in the form of fraction and not whole numbers as we are used to. So you should not meet a question that is giving you a whole number, a fraction as its solution, and say there is a problem. No, there are those questions which require answers to be in fractional form. The second question there, as you can see, the approach is still the same. We are doing it by in a systematic way, by inspection. So we look at this approach. We have both the left-hand side and the right-hand side are all forming, both of them are forming fractions. So it is very important for us to know how to approach this. If you are having such problem, there are two ways. The first way, you'll first move to consider the fraction on the right, deal with it, then move ahead to the fraction on the left and deal with it. Second option is either use the common denominator, the least common denominator between the 6 and the 4, and then that least common denominator, which forms what you call least common multiple, that is, we shall find that it is going to actually have 6 and 4 as its factors. And when we multiply all through, we shall be able to eliminate the denominator. The main purpose here is to eliminate the denominator. So you can go with it as a step-by-step, or you can go solving it using the least common multiple. So here, let's approach it step-by-step. That is what we have. Right-hand side, we have fraction. Left-hand side, we have fraction. So what do we do? So here we shall move by looking at the first one here. Let us remove 6. And to remove 6, multiply here by 6. Multiply that side by 6. Right? Then what you will find that this one will now be removed, will remain with 3x minus 4 equals to 3 times 6, which is 18, That gives us 18 over 4. Because we still have a 4 here, then again we multiply here by 4, multiply here by 4. And when you multiply by 4, you'll have 4 into 3x minus 4 equals to, now this one can be eliminated and remain with 18. So here we have our expression in bracket form. We need to expand using distributive law. So if you use distributive law, it will be 4 times 3, which gives us, that is this one, that one, and then later on with this one, this will give us 12x minus 16 is equals to 18. So this is using distributive law. Now, reaching here, we can now move ahead and approach the question the way we have been doing it by adding 16 here, add 16 here. If you happen to do that now, you'll find that we shall remain with 12x is equals to, 16 has gone now, 18 plus 16. This one is going to give us 34. It's giving us 34. So we find 12x is equals to 34. That is, now the final answer should still have the coefficient of x as 1, so we shall move a step, divide here by 12, divide here by 12, and then remain with x is equals to 34 over 12. When you simplify with common factors, you'll find that 2 is common, so this is 17 over 6. 17 over 6. That's the value of x. Or if you don't want to say that, you'll say x is equals to 2 and 5 over 6. 2 and 5 over 6. So you can always work out this in the best way you are able to. But it's always necessary that we should know how to remove the denominators. And having removed the denominators, when you reach at this point where you have the bracket, use the distributive law, which we covered earlier on in the previous chapters, and then we shall be able to expand and get a simplified expression. Then we move ahead and go by the method we've learned to solve and find the values of x. So we find that this one is in a fraction form, mixed fraction or improper fraction. So now, because we've touched on something here that is touching on distributive law about brackets, now I want to bring in equations that involve brackets. So let us look at equations with brackets. Equations with brackets. Now, this is something we saw earlier on, and we should be comfortable about, we should know about them. These ones, in most cases, we have always come across some questions like 3 into x plus 5. This one is a bracket. It can be simply written as, it is also the same as either 3 times x, which is 3x, plus 3 times 5, which is 15. So this one is expanded form of this. This one is simply expanded form of this. There's no difference when you're looking at these particular problems. And it is advisable that if you happen to work out and expand, then we should always work and understand it in a better way. So this is an expansion situation where we have a bracket and we can always expand. If you saw in when you have a rectangle and you want to find the perimeter, if this was measuring maybe this one was maybe x and this one was y, you'll realize that for this particular case it will be x plus y into bracket 2. That one gives us an expression for a perimeter. When you expand it, it will be 2x plus 2y. But this one is expanded form, where we should always be ready to collect the like terms and so on. So it is necessary that we watch the following. So what should we basically watch when we are dealing with these particular equations which involve brackets? First, we must be able to expand brackets using distributive law. And just to remind you, what does this distributive law actually state? Then you'll learn that the distributive law states like if you have A into B plus C, this one we shall multiply first by this one, then by that is simply equivalent to AB plus AC. That is what distributive law states. So you should be able to simply expand brackets using the distributive law. If it was a minus where we have A into B minus C, then you should maintain A and B to give us AB. And then you see A and minus C will give us minus AC. That is the distributive law of expanding the brackets. Another important thing we need to know, we should be able to identify the like terms. We should be able to identify the like terms. And when we talk about like terms in this particular situation, there are those pronumerals with the same letters, with similar letters. Those are called like terms. So if you have like terms scarcely distributed independently, then you can collect them, you can bring them together, and simply they'll form one term. For example, if you have a number like 3x plus 2 plus 2x, you identify which ones are like terms. And I've said those pronumerals with the similar letters. For this case, we have x here and we have x there. So 3x plus 2x, this one will give us 5x, and then the constant 2. So this one is simply the same as this. That's why we're saying, while expanding brackets, let us take note of the like terms. And the last thing we need to know when we are dealing with this bracket expanded equation with brackets, we say that those equations which involve brackets can be solved fast by expanding and then collecting like terms. Those equations which are involving brackets can be solved first by expanding them. You expand those brackets. After expanding the brackets, now you go ahead and collect the like terms. You have already seen how to expand using distributive law, as we are going to look at the various exercises that we are going to get into right now. So let us look at problems that are related to this and see. We shall look at the prerequisite knowledge concerning the expanding of brackets, and then we advance to solving those questions which have brackets. Expand each of the following. Now, we have some 3 problems, and this one is only asking us to expand, nothing more. Expand using the knowledge that you know about distributive law. Let us start from the first one. If we have 4 into x plus 3, to expand this using distributive law, you will first take 4, multiply by the first one, then again take the same 4, multiply by the second one, maintaining the sign that exists between the two numbers. So this one will give us 4x plus 12. 4x plus 12. That is the expanded form of this when you open the brackets. The second part, again, we have this time 6 into q minus 4. When you work out that 6 into q minus 4, then you'll first use 6 and q, and then 6 and 4. Look at the sign, it's negative, so you should maintain that sign. So this will give us 6q minus 4 times 6, which is 24. This one gives us the expanded form of that particular equation. For the third part, we have 5 into 3a plus 4. Close the bracket. Using distributive law, we go with the first term, that is 5 multiplied by everything in the first area, that is 5 times 3a, which is, and then plus 5 times 4. That is what we shall be getting. When you remove that, you find this one gives us 15a plus 20. 15a plus 20. So this one is the expanded form of this particular question. So why have we done this? We've done this because as we go into solving, we should be able first to expand and then solve. We expand and solve. That is the approach we need to make. Sometimes you'll find that there are those expressions we need to simplify. They have been distributed, but there are some like terms where we shall be required to identify those like terms first before we start solving. So let us look at questions that have like terms and how we can collect the like terms and simplify. Simplify each of the following expressions, and the first expressions we have is 2x plus 5 plus x. The second expression we have is 3a plus 8a plus 2 minus 2a plus 5. Now this one is about like terms. We want to simplify expressions with like terms. So we shall be required to identify what are the like terms. For the first part, like terms are here, where we have 2x and where we have the x. And the sign before x here is a plus, so when we simplify this one, it will be 2x plus x plus 5. 2x plus x will give us 3x, then plus 5. So when you simplify that first particular question, you will get 3x plus 5 as our simplified solution. So our simplified solution. For the second part, we identify the like terms. We have 3a plus 8a plus 2 minus 2a, and then plus 5. Take note that the whole numbers or the constant are also like. If we have 5, we have 4, we can bring them together by adding them together. So what we have here is simply that we have letters, that is the pronumerals, and we also have the constant. Constant can be taken to be like terms. So the like terms that with pronumerals are 8a, 3a, and 2a. We have 3a, 8a, and 2a. So you can write and have 3a plus 8a minus 2a, and then the constant is 2 plus what? Plus 5. Look at how the signs are being written. So all the way from here up to here are like terms of a. And this one's, so this one's here, there is a sign here, and the sign here is 2 plus 2. So 3a plus 8 gives us 11. 11 minus 2a will give us 9a, and then plus, that is 2, 2 plus 5 gives us 7. So when you simplify this, what you'll get, you'll find that you have 9a plus 7 as your simplified expression. So having said this, how do we approach now those questions which are either having brackets, they need to be expanded, or they have got like terms, but this time there are equations where we require to solve and find the values for the pronumerals. So let us look at those equations. We're solving equations by expanding the brackets collecting the like terms where necessary, and finding the values of their known letters.
Yes.
So we have to solve each of these, but it's by first expanding the brackets and then we solve. So the first one is 3 into x plus 2, close the bracket, is equals to 18. Now, looking at this, to expand this using distributive law first, 3 will go by x, that is 3 times x to form 3x, and then 3 again by 2 to give us plus 6 equals to 18. Then from there now, we start our usual method systematically by simply minus 6 here, minus 6 here, and when you do that, you'll find the remaining 3x is equals to 12. That is 18 minus 6 is 12. Then divide by 3, divide by 3, you find that 3x by 3 is x, and 12 divided by 3 gives us 4. So at this particular point, we find that the value of x, given that 3 into x plus 2 in close bracket is equals to 18, then x is equals to 4. As I told you earlier on, you can always check your answer by substituting in the equation and confirming if it will give you equivalent equation. That is it for the first one. That's how we are supposed to approach it. We expanded using distributive law to get this one, and then we moved systematically. The second question is 7 is equals to 7 into 4q minus 3. Now, earlier on I told you sometimes it's always good to interchange the right-hand side and the left-hand side so that you can simply work over it a bit easier. So I advise that the same can apply here so that we interchange the right-hand side and the left-hand side and move on. If you choose to do that, you'll find that now here what we shall have will be 7 into 4q minus 3 is equals to 7. I've not changed anything, I've only interchanged. So then the first thing, using distributive law, open the brackets, that is 7 times 4q, which will give us 28q, and then 7 times minus 3, which will give us 21. The other side, we didn't have a bracket, we don't have anything to multiply with, so the constant remains, that is equals to 7. That is what we have. So realize now from this point we have the first step systematically where we shall add 21 this side and add 21 the other side. If you do that, you'll find that minus 21 plus 21 is 0. We shall remain with 28q is equals to 7 plus 21, which gives us 28. Now, having reached here 28q is equals to 28, we want to remain with q. Divide this side by 28, you'll get q is equals to, divide here by 28. When you divide by 28 here, you find that 28 divided by 28 will give us a 1. It will give us a 1. So we can simply conclude and say that q is equals to 1. Q is equals to 1. Take note on how we approach that. It's not a must to interchange the left-hand side and the right-hand side, but sometimes you do it so that you can work with your equation a bit easier. Now, the third question that we have is 3 into bracket, we have b plus 5, close the bracket, and then plus 4b equals to 29. So this one will require us to open the brackets, it will require us to collect the like terms and so on. So as we look at that, 3 into b plus 5, close bracket, plus 4b equals to 29. Using distributive law, you have to open this, And that will mean that 3 by b is 3b, plus 3 multiplied by 5, that gives us 15, plus 4b will remain, and then equals to 29. When you look at this, we should be able to collect the like terms, and we have a 4b here, we have a 3b here, which can be, both of them are all positive, you can add them together. So this one will be 3b plus 4b plus 15 equals to 29. When you add this one, it will give us 7b, that is 3b and 4b gives us 7b plus 15 is equals to 29. Now here we have an expression that can now be dealt with systematically. So we shall first tackle by removing 15 on the left and remove 15 on the right. So 7b plus 15 minus 15, you remain with 7b, and then 29 minus 15, you remain with 14. So for 7b is equals to 14. We are interested in finding the unknown b, where the coefficient is simply 1. Therefore, we shall move ahead and divide this side by 7 and divide this side by 7. When 7b is divided by 7, you remain with b is equals to 14 divided by 7, which gives us 2. So you can conclude there and say that b is equals to 2. b is equals to 2. Take note of the following, that there was that need to expand using distributive law, then there was need to collect the like terms. After collecting like terms, then you solve systematically. So to approach questions touching on expansion, that is brackets, we need to have all the knowledge right from where we started about the equations, how we were expanding them, how we were collecting the like terms, and then we start solving the question by the moving systematically. So we need to have those knowledge. Let us look at another question. Now, this one is going to be a bit different, whereby we are going to introduce multiple brackets. But remember what is very important, as long as you know how to remove the brackets by distributive law, and then you collect the like terms, there is no big difference. You will reduce that expression to just come back to a simple equation, and you're able to solve. I want us to look at equations with multiple brackets. Equations with multiple brackets. Now, looking at this question, we have multiple brackets. We have got brackets here, we have got brackets here. So we are expected at least to use the law, distributive law, to remove the brackets in both areas. So this question states that we are supposed to solve 3 into bracket 4a plus 5, close the bracket, then plus 5 into bracket, we have 1 plus 3a, close bracket, equals to 47. So to approach this, let us look at this area and then also this area. We have got a way where we shall be required to apply distributive law in each area. So using distributive law, 3 multiplied by 4a, so we shall have this one as 3 times 4a to form that first part, then plus 3 multiplied by 5. So we are done with this part. We go ahead, this is 5, and then inside the bracket we have to apply distributive law. So 5 times 1, and then the sign is plus 5 times 3a. So we are done with the distributive law again in the second bracket, but the final answer should give us 47. So looking at that, 3 times 4a gives us 12a plus 15 plus here is 5 plus this is 15a, that is 5 times 3a. This is equals to 47. As we look at them and collect like terms, we have 12a, we have 15a, we have 15, and we have 5. So we need to collect the like terms. So this will be 12a plus 15a plus 15 plus 5 equals to 47. 12 and 15 can be combined to form 27. They can be combined to form 27. And then 15 plus 5 is 20, is equals to 47. From here, we have now reduced our expression. So we minus 20. We minus 20 both sides. So that we shall have 27a equals to 27. From here, we divide by 27 to remain with a equals to 27 divided by 27 will give us 1. So this is how we approach when we have multiple brackets, and we can always work out these problems without any issue up to the end. So that is it for today. I hope you've enjoyed the lesson. Thank you.